Good morning, Star Louisians. Last time we discussed about the mathematical equation, and that is one type of mathematical sentence that involves equality symbol, and that is the linear equation. So for this time, we shall be dealing with another mathematical sentence, and that is all about the inequality. For inequality class, the differences between equation and inequality is the symbol that we're going to use. So from the word equation, we will be using the equality symbol, and from the word inequality, we'll be using the inequalities symbols. And these are your is greater than or equal to, is less than or equal to, is greater than, and is less than. So, what do you mean by inequality? So, any inequality compares two quantities and typically uses one of these symbols. So, from the word, it compares two quantities. So, meaning we have your left-hand member and we have your right-hand member. And what are the symbols to be used in comparing two quantities? These are, first, we have your is less than, and then we have your is greater than, and then we have your is less than or equal to, and then we also have your is greater than or equal to. So class, for you to memorize the symbol is less than or is greater than. So this is how you're going to write it. So from the word is less than, okay, so you have your L is less than. This is the symbol. And then we have your is greater than. Then we put G here. Okay, so that is greater than. Remember that the inequality symbol opens to the side with the greater number. Example, we have here 2 being compared with 10. So where is the opening? Okay, so the symbol opens to the side with the greater number. So your 10 is the greater number. So therefore, it opens to the side where is the greater number, and that is your 10. So if we're going to read this, it would be 2 is less than 10. So an inequality that contains a variable is an algebraic inequality. A number that makes an inequality true is the solution of the inequality. Just like in algebraic equation, particularly your linear equation, we also have your solution set, right? But in the linear equation, we only have one possible value of your x. So we have only one solution set of that given equation. Unlike in algebraic inequality, the solution set would be a range of something, okay? So example, we have your x is greater than 2. So what are the possible values of x which are greater than 2? So we could have your 3, we could have your 2.01, we could have your 2 and 1/4. So it can be a decimal, it can be a fraction, it can be a whole. Okay, so those are the different ranges of the solution set of that x is greater than 2. So the set of all solutions is called the solution set. And the solution set can be shown by graphing it on a number line. In a linear equation class, we find the solution set by merely solving it. And if you're going to graph that, the point, or the point, example, we have your x is equal to 2. So if we're going to graph that, the answer during the graph is just your 2. Well, here in graphing, we could have, example, x is greater than 2. So we can show what are the possible values by showing the graph in the number line. Okay, always remember again that the question is, what does an open or closed circle denote in the graph of the inequality? Take note, an open circle means that the corresponding value is not a solution of that inequality. A solid circle means that the value is a part of the solution set. Okay, let's have example number 1. The given is x is greater than 0. And what are the possible solutions of x is greater than 0? We could have your x as your 1/2 because your 1/2 is greater than your 0. X could have 1 because your 1 is greater than 0. Your x could be 25, right? Yes, because your 25 is greater than 0. But could we have a value of x which is -1? It's not because your -1 is less than your 0. So -1 now is not a solution set of that given inequality x is greater than 0. Now here in the symbol, it says here is greater than. So there is no bar here in which it would say it's greater than or equal to. So here in the example, x is greater than 0. Your 0 is not an answer, is not a solution of this inequality because it says there x is greater than your 0. So what are the possible values? It would have 0.21, we have 1/2, +3, +4, +5, but your x that are less than 0 would not be the solution set of that inequality. And your 0 is also not a part of the solution set of that given inequality. So if we are going to write that or to graph the given solution set now, it would be, we have now here the open circle. So we write here open circle in 0 because your 0 is not included. And we have to the right of 0. So meaning to say that the solution set is to the right of 0 and 0 is not included. So it's shaded on the portion to the right of 0, but your 0 is not included in the solution set. That's why we did not shade the circle in 0. Okay? So if we're going to write also the interval of that, it would become parenthesis 0 and then to the positive infinity. Why to the positive infinity? Because the answer is to the right of 0. Okay, before we proceed further, may we have a mastery on how to write solution set in interval notation. Okay, so this is how we're going to write it. If your x is greater than 0 and your x is less than 0, this is how we are going to write it. Okay, we have here parentheses, we have 0, and then positive infinity parentheses. Okay, why is it that we started writing on 0? Because in writing solution set in interval notation, you start with the lower value and then followed by the higher value. Because we all know for a fact that the positive infinity is greater than your 0. Okay? So here also is x is less than 0. So writing first to the lower value. So since it's less than 0, what are the possible values of less than 0? These are your negative numbers. Therefore, we have negative infinity and then 0. Then we have also here your open parentheses and your close parentheses. Okay, let's have another one. The inequality, we have your negative infinity and then 5. Okay, we have here your x. Since the negative infinity came first, so we have your x is less than. Is it less than? Okay, it's less than positive 5. Let's see if it's correct. Okay, very good. It's x is less than 5. And what are the possible values of your x? We have your 4, we have your 3, we have your 4 is less than 5, correct? Then we have 2.1. 2.1 is less than your 5, so it's correct. Now, question is 5 included in the solution set? No, it's not included. Therefore, if you're going to graph it, you have open circle to your 5, okay? And then, where is the movement now? Where is the arrow? Okay, the arrow would be to the left of your 5 because it's less than. So since it's less than, the arrow should be to the left. Okay? If it is greater than, the arrow should be to the right. Okay, so the difference now of your is greater than and is your less than now. So in the is less than part, so let's say your x is less than your 5. So here we have your parenthesis, negative infinity. Why? Because your negative infinity is lower than your 5. And then we have here 5 close parentheses. What about if the given is x is greater than 5? So since it's greater than, and if you're going to write in interval notation, so from the word is greater than 5, so what would be the possible, okay, minimum? It would be your 5. But you're going to write open parenthesis because your 5 is not included. And then comma, what would be the maximum? It would be your positive infinity because from the word is greater than. Now the question is, why is it that we place open and close parentheses for infinity? It's because you do not know what would be the end of that given answer. Okay, so it's excluded because let's say we have your x is greater than 3. Therefore, the answer would be the lowest possible value would be your 3, but excluding your 3, so it would be open parenthesis 3 and then positive infinity close parenthesis. Okay, let's have this one. In our example a while ago, we have your 0, you have your negative infinity, and then we have your 5. Okay? And they are all close and open parentheses. We also have your 2, and then we have your positive infinity. It's still open and close parentheses. But in our third example class, you have noticed that there is a bracket. Okay? There is a bracket before your 3. So the bracket would mean that your 3 is included. I'll repeat. Your bracket symbol would mean that the given number is included as the solution set. Okay? So here now, the value of your x would range from your 3 to the positive infinity. So meaning your answer would be x is greater than or equal to your 3. Let's check if it's correct. Okay, your x is greater than or equal to your 3. You have noticed that there is a bar here. So this would mean is greater than or equal to your 3. So your 3 is included. But in x is greater than your 3 is not included. That's why it's parenthesis, open parenthesis 3, and then to the positive infinity parentheses. While in x is greater than or equal to 3, your 3, before your 3 is a shaded, therefore it's bracket. Okay, bracket 3, and then positive infinity, we have close parentheses. And what are the possible solution set for that? Could we have your 3 as the value of your x? Yes, because from the symbol that is being used is greater than or equal, therefore your 3 is a part of the given value of x. So your 3 to the positive infinity. So 3.01, 3, 3.2, 3.5, 3 and 3/4, then 4, 5, 6, 7, 8, 9, 10, and so on and so forth. Okay, so what would be the possible solutions now? We have your x is equal to 3. Yes, your 3 is the solution set of that. Okay? And then your x is equal to 17. Yes, because your 17 is greater than or equal to your 3. And how do you graph it? Of course, we have your shaded. And where is this shaded circle? Okay? Where are you going to put the shaded circle? Of course, you're going to put the shaded circle on the minimum value, and that is your 3. Okay? And then since it's greater than, therefore, the possible values would be from your 3 to the right. Okay, from your 3 to the right. So we have here the given graph of that given inequality. And what is the interval notation? We have bracket 3 and then in positive infinity, open parenthesis. Okay, let's have this one. What about this? Okay, there must be negative here because your negative infinity is to the left. Okay, so in writing again your interval notation, always remember you start from the lowest possible value and then you have comma and then the highest value. So here, it's just an error. There must be a negative symbol here, class. So negative infinity, and then 2, and then bracket. So since your negative infinity came first, therefore it must be less than. But your 2 has a bracket, so meaning to say it's included. Therefore, we have your x is less than or equal to your 2. And let's check if it's correct. Okay, so x is less than or equal to your 2. Now, what would be the sample solutions? Is your 2 included? Yes, because of the word is less than or equal to. So your 2 is included. Okay, what about your 1.2? Yes, because 1.2 is less than your 2. What about your 0? Yes, because your 0 is less than or equal to your 2. What about your 2 again? Yes, because your 2 is less than or equal to your 2. So these are the possible solutions. What about if we have your 5? No, it's not correct because your 5 is greater than your 2 and that is not a possible solution for that. Now, let's graph. How do you graph it? Since there is an inequality that is less than or equal to, that would tell that the 2 now is to be shaded. Okay, so your 2 has a solid figure, so 2, and then since they're talking for less than, therefore from 2 to the left. Okay, from 2 to the left. So let's check. Okay, it's 2 to the left. Now, so in life, we have different examples of inequalities in life. Let's have this example. The school can send at most 6 delegates to a national student assembly. What are the possible number of students that the school can send to the assembly? Okay, let's check. From the word at most. Okay, your at most would tell that what would be the maximum? Is it the maximum or the minimum? Okay, from the word at most, meaning that it must be less than or equal to 6. Let's check if it's correct. So your at most means that it represents that it is x or is less than or equal to 6. From the word at most, you will be using your less than, is less than, or equal to symbol. So meaning to say that the maximum number of participants is 6. So could we have 5 as the number of participants there? Yes, because from the word at most, the maximum is 6. So from 6 to, could we have 0 as the number of participants? Yes. But could we have negative? It cannot be because we're talking for person. Okay, so it must be a whole number. So from 0 to 6. Could we have 7? No, because the maximum is 6. Okay, so the fare hike will not be more than 2 pesos. So from the word will not be more than, it would be x is less than or equal to 2. So it could be 2 pesos, it could be 1 peso, it could be 1.75, it could be 1.5, it could be 0.5, it could be 0.25, but your negative could not be an answer of that. Okay? So we have here another. The minimum car speed X in the expressway is 60 kilometer per hour. So from the word minimum, meaning it would be 60 and above. So the answer is X is greater than or equal to 60. So when you say maximum, it must be at most. So the greatest would be the given value of your X. But here in the minimum, it must be the lowest possible value is the given in the given statement. Okay. The amount of water a person should drink in a day should be more than 5 glasses. The amount of water a person should drink in a day should be more than 5 glasses. So what would be your clue? More than 5 glasses. So the answer is X is greater than 5. So it must be 5 point something and above. But since we're talking for glasses now, we're talking for that full, okay? So it must be 5, it must be 6, 7, 8, and so on and so forth. But your 5 is not included. Okay, still, the time it takes to process the documents, X is less than a week. Okay, from the word less than, and since a week composed of 7 days, therefore your X is less than 7. Okay, then we have now, what are the properties of the inequality? In the linear equation, we also have the properties of equality. And this equality, we use this as our guide in solving for the value of your x. Whether in the given, there are variables on both sides of the equation, the same variable, or there is a variable on one side of the equation, we use the different properties of the equality. And those are your addition property, subtraction property, multiplication property, we have your division property of equalities. So here we will be dealing with the properties of inequalities. And these properties of inequality will be used in solving for the value of x or for the solution set in the given inequality. And what would be the first one? We have your trichotomy property. Trichotomy property states that for any numbers A and B, only one of the following is true. So it's either your A is equal to your B, A is greater than your B, so your A is less than your B. So here, class, there is one inequality symbol used and there is one inequality statement in the given. So let's have example. Your 9 is less than 12. Yeah, it's correct. Your 9 is less than 12. And what is the inequality symbol? It's less than. 23 is greater than 12. Yeah, it's 23 is greater than 12. And what is the symbol? Inequality symbol is greater than. And then we have your x plus 2 is greater than your 8. And what is the inequality symbol? It's only your is greater than. So that is your trichotomy property. For numbers A and B, only one of the following is true. It's either your A is greater than your B or your A is less than your B. Okay, we have your transitive property of inequality. For any numbers A and B, only one of the following is true. So here, if A is greater than your B and your B is greater than your C. So here there are two inequalities being compared, okay? Your A is greater than your B. So your A is greater than your B and B is greater than your C. So what would be the final conclusion or the conclusion of that? It would be your A is greater than your C. Okay? So if your A is greater than your B and B is greater than your C, therefore your A is greater than your C. In like manner, if your A is less than your B and B is less than your C, then your A is less than your C. Let's have example. If 15 is greater than 11, is it correct? Yeah, it's correct. In trichotomy, is 15 greater than 11? Yes. And if your 11 is greater than 15, is it also correct? Yes, 11 is greater than your 15. What is your A here? Your A is your 15 and your B is your 11. So if A is greater than your B and 11, which is your B, is greater than your C. And what is your C? It's 5. So let's check. Is 15 is greater than 11? Yes. Therefore, your 11 is greater than 5? Yes. So what is the conclusion? What is your A? Your 15 is greater than your C. And what is your C? It's your 5. So your A is greater than your C. Okay, let's have another one. If x minus 1 is less than your 8, what is your A? X minus 1 is less than your B, which is your 8. And your 8, which is your B, is less than your C. Therefore, in the conclusion, we have now your x minus 1. What is this x minus 1? It's your A. And what is this x? It's your x. So it's less than your C. Okay, so let's check. If A is less than B and B is less than C, therefore your A is less than C. Okay, let's have another one. Addition property of inequality. For addition property of inequality now, what's the difference between addition property of equality and addition property of inequality? Let's try to discover here. Okay, if the same number is added to both sides to retain the inequality, one of the following is true. So if A is greater than B, then what did we do? We added C on both sides of the equation, of the inequality, I should say. So if A is greater than B, then A plus C is greater than B plus C. So in like manner, in addition property of equality, the difference also, the differences would be just the symbol. Okay? So we use equality symbol in addition property of equality, but in inequality, we use the inequality symbol, and that is your is greater than and is less than. Okay, so if A is less than B, then A plus C is less than B plus C. So if A is less than B, then A plus negative C is less than B plus negative C. Take note, class. Whatever you added to the left, you also add it to the right. So the same, huh? The same. So if you add 2 to the left, you also add 2 to the right. Okay? So here in the example, if x plus 3 is greater than 7, then x plus 3 plus 8 is greater than 7 plus 8. So what did we add on both sides of the inequality? We have your A, your C, I should say, as your 8 to the left, and we have also 8 here to the right. Okay? In like manner, in the second example, if x is less than 8, then x minus 1 is less than 8 minus 1. So what did we subtract? We subtracted 1 to the left, from the to the left side of the inequality, and then we subtracted also 8 to your 8, which is part of the right side of the inequality. So in the addition property class, it's just like adding or adding the number or adding the opposite of that number, but it must be the same. Whatever you add to the right, you also add it to the left. Okay, let's have another one. Multiplication property of inequality. If the same number is multiplied to both sides to retain the inequality, one of the following is true. So here you just multiply a number to both sides of the inequality. Okay? But there would be a condition. If A is greater than your B and C is greater than your 0, then AC is greater than your BC. Oh, there is a restriction here, class. There is a restriction. If your A is greater than your B and C is greater than 0, meaning it's positively signed, the values of C must be positive, then your AC is greater than your BC. So the original inequality now is greater than. Therefore, the answer is also is greater than if you multiplied C, which is greater than 0. But take note of this. And the second one, if your A is greater than your B and your C is less than your 0, what would happen to the concluding answer or to the answer? Okay, your AC is less than your BC. So meaning to say, if you multiply or divide a negative number to both sides of the inequality, the original inequality will just reverse its signs. It would become is less than. So if it is less than on the original and you multiplied negative or you divided negative, then it would be is greater than on the concluding part. But if you multiplied positive, then the inequality symbol will not change. Okay, let's have example. If your x is greater than your 5, then 3x is greater than 15. So meaning the possible values of your x would be it would be again is greater than 5, so therefore it would be 5 point something, 6, and so on and so forth to the right of your 5. So since your C is positive and it is less than 0, therefore your 3x is still greater than your 15. Okay, let's have another. If x plus 2 is less than x minus 4, then x plus 2 times 8 is less than x minus 4 times 8. Okay, here class, there must be a parenthesis here. Your x plus 2 is being multiplied by your 8. The whole x plus 2 is being multiplied by your 8. Therefore, the whole x minus 4 is also being multiplied by your 8. Why is it that the sign of the inequality did not change? Because we multiplied both sides of the inequality, a positive number which is greater than 0, and that is your 8. I'll repeat. This must be the whole parenthesis x plus 2 is being multiplied by your 8. And the whole parenthesis x minus 4 is also being multiplied by your 8. Okay, in layman's term, okay, let's have an example here. So if A is greater than your B, let's say we have your 5, is greater than your 2. Okay, so this is your A, which is your 5, and B is greater than 2. And your C is greater than 0. So let's have 5 times 2 is greater than 2 times 2. What is our original inequality? Is greater than symbol. Let's check if our final answer would be still is greater than. So 5 times 2, 10. Is greater than 2 times 2, 4. So is the inequality symbol changed in the final answer? Does not change, right? Because we multiplied C, which is greater than 0, and that is positive. What about if we multiply negative? Okay, let's check. Your 5 is greater than your 2. It's correct. So your A is greater than your B. Correct. What if we multiply C, which is less than 0? Let's check. 5 times negative 3 blank 2 times negative 3. Okay. 5 times negative 3, negative 15. 2 times negative 3, negative 6. Is your 15, negative 15 is less than or is greater than your negative 6? Is less than. Therefore, what is the final answer? It must be is less than. So, the inequality nag-change yung sign ng inequality because you multiplied less than 0 to both sides of the equation. Sorry, of the inequality.